Good afternoon, children. So, as I said yesterday, today we are going to start in group 16 elements. Okay, group 16 element. These are also belongs to P block elements. So, in that we are going to deal with the group 16 element. So, what does the group 16 element consist of? So, here they are also comes under 6th group elements, right? So, what are the elements comes under 6th group or group 16 elements are oxygen, sulfur, selenium, tellurium and polonium. If you go with their symbols, that is oxygen O, sulfur S, selenium Se, tellurium Te, polonium PO. You see their atomic number. Comes to the atomic number. Oxygen 8, sulfur 16, selenium 34, tellurium 52 and polonium 84. So if you want to memorize these atomic numbers, it is where there is a trick, that is you should add 8, 18, 18 and 32. So first atomic number you have to memorize, that is oxygen 8. To this 8 you should add another 8, that is a sulfur. You are going to get this atomic number 16. For this 16 you have to add 18. Yes, next one is 18 only, no? So you are going to get 34, that is selenium. To this 34 again add 18, you are going to get 52. To this again you should add 32. So 52 plus 32, it is 84. Very simple. This is a trick. You have to memorize this atomic number. If you remember only atomic number of oxygen, it will be enough. 8, 18, 18, 32. To this 8, 18, 18, 32. You are going to get this. And if you see the electronic configuration, see, look at here. We are going to get the stable electronic configuration as it is having in outermost shell 6 electrons. Yes. So the oxygen atomic number is 8. So helium 2s2 2p4. And next the sulfur atomic number is 16. If we go with their electronic configuration, that is a neon 3s2 3p4. And next one selenium, that is argon 3d10 4s2 4p4. And next tellurium atomic number 52, krypton 4d10 5s2 5p4. And polonium 84, that is a xenon 4f14 5d10 6s2 6p4. So ultimately what is the last electronic configuration we are going to get? 2s2 2p4, that means ns2 np4. The general electronic configuration of this group 16 element is ns2 np4. So they are also called the elements of oxygen family. Why they are called as oxygen family? The starting element of this group is oxygen. So that is why they are called as oxygen family. Sometimes they are also called as oxygen sulfur family, and they are also having the name called chalcogens because of their ability to form minerals. Okay, because of their ability to form minerals, they are also called as chalcogens. Understand, children? So look at here the general electronic configuration. What I said, ns2 np4. In ns2 s mean in s subshell, how many electrons are there? 2. So I am writing 2 here. And in p, how many are there? 4. So you have to fill first half, 1 2 3, and last one comes here. So it is having 2 unpaired electrons in their sublevel p shell, right? Yes. So this is the general electronic configuration. Next, move to the occurrence. So oxygen can be occurred in a free state. Okay. So oxygen can be occurred as in a free state as a dioxygen, that is O2. Okay, oxygen comprises of about 21% of the Earth atmosphere by volume. Okay, 21% of the Earth atmosphere by volume, it consists of oxygen. And in Earth crust, the oxygen is the most abundant element of the Earth crust. It makes up nearly 46% of the mass of Earth crust. Yes. So oxygen is very much important. Oxygen is commercially prepared by fractional distillation of liquid air. It is prepared in the laboratory by thermal decomposition of potassium chlorate in the presence of manganese dioxide as catalyst, and a decomposition of KMnO4, potassium permanganate, and nitrates of alkali metals except lithium. Right, children? And oxygen is a colorless, odorless, liquefies at 90 Kelvin, and whatever oxygen we are taking is a colorless gas and it's an odorless gas, isn't it? And it is soluble in water. Its solubility in water is less, about 3.08 cc in 100 cc of water at 293 Kelvin. So which is just sufficient as a dissolved oxygen for a vital marine life. So it is sufficient for vital marine life. And if we go with their isotopes of oxygen, there are 3 stable isotopes of oxygen. What are the 3 isotopes of oxygen? O816, O817, O818, isn't it? And molecular oxygen is paramagnetic in nature. And oxygen is directly reacts nearly with all non-metals and metals except noble gases and like metals like gold and platinum. And essentially now we are going to see their physical properties. So look at here, oxygen and sulfur occur widely in nature as oxides and sulfides and sulfates. So oxygen and sulfur combines widely to give their oxides, sulfides and sulfates. So the important minerals are, so look at here, I have written some of the important sulfides and sulfates. First one is galena. Galena formula is PbS. Okay, PbS, where sulfur combines with the lead. And next one, zinc blendy, that is zinc sulfide. Copper pyrites, that is CuFeS2. Okay, so these are the sulfides. When this sulfur and oxygen combines, what are the things we are going to get is sulfates. Okay, SO4 you are going to get that one. First one is gypsum, that is calcium sulfate 2H2O. And Epsom salt, you know Epsom salt, yes, magnesium sulfate 7H2O. And barytes, that is barium sulfate. So when oxygen and sulfur combines, we are going to get sulfates. Only sulfide when combines with some of their metals, we are going to get this galena, zinc blendy and copper pyrites. Now we will move into the general properties. So what happens to the atomic radius? Atomic radius, if we move down the group from oxygen to polonium, it increases. Why it increases, children? As the atomic number increases, the number of shells is going to be increases. As the number of shells is going to be increases, the distance between the center of the nucleus and the outermost shell increases. That means the radius also increases, right? Yes. So atomic radius increases from oxygen to polonium. Next comes to electronegativity. So what happens to the electronegativity? Electronegativity decreases. So in previous also we have discussed why electronegativity decreases. Electronegativity means the pulling capacity of an electron towards the nucleus. Yes. So if you move down the group, the atomic number increases, the number of shells increases, and the distance between the nucleus and outermost shell, outermost electron also increases. When it increases, it is very easy to remove the electron from means it's very easy to pull away the electron from the nucleus, right? So when number of shells increases, the distance between the nucleus and the outermost shell increases. So it is enough, means it requires less amount of energy to take away this electron. So that is why the electronegativity decreases down the group. Next comes to electron affinity. Electron affinity is nothing but electron gain enthalpy. So electron gain enthalpy of oxygen is less negative than that of the sulfur because oxygen is compact in nature. If we say their order of electron affinity, gaining capacity, yes. So here sulfur is greater than selenium is greater than tellurium is greater than oxygen. That means this shows the electron affinity order. The order of electron affinity is S, Se, Te and O. Selenium, tellurium and oxygen. Next comes to ionization energy or ionization enthalpy. This also decreases down the group due to poor shielding effect of inner d orbitals. Okay, ionization enthalpy also decreases due to their poor shielding effect of inner d orbitals. Next comes to density. What happens to the density when you move from oxygen to polonium? As the atomic number increases, the density also increases from oxygen to polonium. Next comes to melting and boiling point. Melting and boiling point, it increases from oxygen to tellurium, and a suddenly rise in temperature also we can observe in these elements. Next comes to metallic nature. Metallic nature increases. Why metallic nature increases? Due to increase in atomic size. When an element shows metallic nature, when it donates an electron, it shows metallic nature. So when you move from oxygen to polonium. Yes, so oxygen is a non-metal. Why? Because the electrons are very near to their nucleus. When it comes to the polonium, it is far away from the nucleus. So it is very easy to remove the electron. So when they are easily remove their electron, they shows their metallic character. So due to the increase in the atomic size, the distance between the nucleus and the outermost shell increases. When it increases, the attraction between the nucleus and outermost electron decreases. So when it decreases, it is easy to remove the electron from the outermost shell, right? So due to basing on this concept, metallic nature increases when you move from oxygen to polonium. So here, look at here, oxygen and sulfur are non-metals. Selenium and tellurium are metalloid, that means they show the character of both metals and non-metals. And polonium are purely metal, though they are radioactivity element, they are a pure metals. Next comes to atomicity. So what do you mean by atomicity, children? Atomicity is nothing but a number of atoms combined in one, what I said, atomicity. So atomicity is nothing but a number of atoms combined. Okay, number of atoms present in one molecule of an element is called atomicity. So here oxygen is a diatomic molecule. Oxygen is a diatomic molecule with a double bond between the two bonded atoms. So the double bond contains one sigma and one pi bond, one sigma and one pi bond. If we move to this sulfur, selenium and tellurium, they are octaatomic molecules. They are octaatomic molecule, that means they combined with 8 atoms of the same element. So look at here, sulfur 8, S8, Se8 and tellurium 8. That means, so when 8 sulfur atoms combine, okay, they show the different forms of structures. Yes, they form crown shaped molecule. Okay, they form crown shaped molecule, which is also called puckered ring, and they also form chair shaped molecule. So look at here, when if you see the structure of S8 and S6, first we are going to look at S8. So 8 sulfur atoms, 1 2 3 4 5 6 7 8. If you join all these things, how it looks like, children? It looks like a crown. So they form crown shaped molecule. This crown shaped molecule is also called puckered ring. Okay, puckered ring molecule or puckered ring S8 molecule. If you see the another structure, here we are taking S6. So 6 atoms of sulfur, 1 2 3 4 5 6. So if you see their structure, they looks like a chair. Okay, they forms another form of structure, that is a chair molecule. So if you see the structure, so these are the structures of S8 and S6. So these are the physical properties of group 16 elements. In the next class, we are going to deal with the chemical properties of group 16 elements. Thank you, children. If you really like the video, give a thumbs up icon, then I will be very happy. That means it boosts up to make more and more videos. And at the last of this topics, I am going to discuss some tricks to memorize the topic very easily. Thank you, children.